We want to start with the second part of our sessions today, and I would love to welcome on stage Kevin from the SCION Association. I would love to say live from Swiss, but he is coming from the Netherlands, but it is a project which is famous from Swiss, and he will talk about SCION today.
Okay. All right, thank you very much. And not only am I from the Netherlands, but I'm also British and not Dutch, so just to confuse everyone further. But yeah, thank you for inviting me here. It's actually my second time in Oman. I came 5 years ago. I can't remember if I've been to a MENOG before. I think I may have been to one before, but I'm not completely sure. But it's great to be here, and it's actually great to be back in Oman again. I took a bit of a trip around the country last time, and yeah, it was fantastic. But I wanted to talk about SCION, which is really looking to address some of the routing security issues on the internet, partly to raise some awareness of this, but also to highlight that SCION is a possible technology that can address some of these issues. So SCION is basically a path-aware internet routing architecture. It's primarily based in Switzerland at the moment, but it is actually used in a research and education network, which has connections to actually quite a few countries in the world, and not just in Europe either. It has connections to North America, Asia Pacific, and also in Latin America. But okay, to the problem. So as of about 2 days ago, there were nearly 77,000 autonomous systems connected to the internet. And there were around 990,000 advertised IP prefixes. Now, you'll be familiar perhaps with the BGP system, which allows all of these ASs to interconnect with each other. And the result of this is that there are actually a lot of possible paths across the internet. This CAIDA diagram is a little bit out of date. They haven't actually updated it for a few years, but it's really there to just illustrate that this is really a spider's web of possible paths, and it's also sometimes very difficult to determine exactly where your traffic is going across the internet. Now, I think there's been talks at MENOG before, and certainly this awareness of this problem has been raised in the last few years through initiatives like the Manners, and the RIPE NCC has been doing a lot of work to encourage the uptake of RPKI. So the problem with BGP is that it's inherently based on unverified trust, and there isn't any built-in validation that route advertisements are legitimate. So in practice, this means that any network can announce any ASN or IP prefix, and essentially any network can masquerade as another network. But in particular, the sending and receiving networks have very limited options to decide how their traffic actually crosses the internet. Now, why is this a problem? So perhaps you'll be familiar with route leaks, which is a sort of unintended consequences of misconfigurations where traffic goes via a longer path, or a path that's not intended, or a congested path, and this has led to some rather famous outages. Perhaps the VeriSign one is perhaps the best known, which was about 5 years ago. Then you also have the route hijacks. This is much more of a malicious act. This is often done by, sometimes it's done by nation states, other times it's done by just criminal actors, really to reroute traffic to a particular destination, sometimes for black holing reasons, sometimes to do traffic interception. But then the one that is perhaps less well known and less discussed is actually data sovereignty breaches. So you don't hear so much about this, but often BGP is sending traffic across different geopolitical boundaries. In many cases, this isn't a problem, and in fact, it's a desired effect of the internet. But in other cases, this can breach national and, in some cases, for example, EU data protection legislation. And in fact, there was a case fairly recently where some Australian healthcare information was sent from the Northern Territory to a site in the New South Wales, and this actually ended up going for a third-party country, completely breaching the data protection requirements in that country. So this is a real thing, and it's really happening. Okay, so none of this is new. This has been a known problem for quite some years. And there's been a number of things being done to try to address this. Perhaps the best known of this is RPKI. Again, there's been a big push from the RIPE NCC for network operators to sign their prefixes with route origin authorizations. But one of the issues with this, for the widespread deployment to be effective, you need to really have a lot of networks doing this. And I think at the moment we're just over 50% of all the IP prefixes in the world, which is great. This has grown a lot in the last few years, but the issue is that, okay, it's nice to sign your number resources, but actually you've actually then got to validate those. And at the moment, only about 5% of networks are actually doing this. So although some of these resources are signed, many of these resources are signed, they're not actually being validated at the moment. Then you had BGP-SEC. So this was a protocol developed more than 10 years ago, I think. It was standardized through the IETF. And this really is there to introduce cryptographic assertions on each hop of a route across the network. So in other words, it's more difficult to insert unauthorized ASNs into the path. One of the issues with this is that it does need to be explicitly supported by all the routers across the network path to get the full benefits. 15 years ago, the computational requirements were a bit of an issue. That's probably less so now. But there are delays. This does cause delays in route convergence. So when a link goes down, it takes a while to recompute the paths. Big problem is there's almost no deployment of this at the moment as well for various reasons. So part of to address this further, there was another initiative, and actually my colleague, former colleague Max, who's sitting at the back there, was involved in this initiative called ASPER. So this works out of band in a similar way to authorize the intermediate paths. But again, I think this, Max may correct me, I think this is not yet standardized through the IETF, and it's not widely deployed at the moment. So this is where SCION comes along. This has been an issue for a number of industries for a while, and so SCION was developed to address some of these concerns. Okay, so who has this problem? But, for most people that use the internet, maybe this isn't a problem. But there is a lot of critical infrastructure out there at the moment that does need replacing. And it's not necessarily in the places that you're aware of. Particularly in the power and transport and emergency service networks, they have a lot of legacy stuff, and some of this is not fully networked, and a lot of this is not actually IP-based. So this is getting very old, it's getting very aged, and it's becoming very expensive and very hard to support these legacy infrastructures. The equipment's getting old, it's not being made anymore. It's difficult to find people to support this equipment. So a lot of these networks are now, well, not really networks in some cases. Some of these organizations are saying, well, actually, we need to look to the internet to replace this. The internet is now reliable, it's well understood, it's resilient enough. There's multiple service providers, there's multiple pathways across the network. And we can, as with something like the electricity grid, this is now reliable enough for us to run critical infrastructure on. But they do need to have certain security, and they need certain data sovereignty assurances to run this. And this is one of the places where SCION can come in and can help with that. Because SCION can support true interdomain and multi-ISP support, unlike some of the other sort of potential solutions that you could think of, like VPNs. One example is air traffic control. This is and I was very surprised about this, I must say, when we had these discussions with some various air traffic control organizations. it was really an eye-opener to understand that this is really running on a very legacy protocol, like a serial protocol. It's something called OLDI. This runs between area control centers, but this is only within the core of the air traffic control system. There's actually, for some of the outlying airports and outlying control centers, this works by the telephone. They literally telephone flight plans to each other. Now, this doesn't actually need to be particularly, this doesn't use huge amounts of bandwidth. It's actually not as time critical as you might imagine. So, you know, it's time critical within a few minutes, but probably not within nanoseconds. But it is something that does need to be secure, and it is important to ensure where that data is going. So this is really a very good use case of a very legacy infrastructure that needs to be replaced. They'd like to replace it with the internet from commodity service providers, but of course, as you will understand, you know, it has to be, it's very, this data does need to be traffic needs to be sent very securely. Okay, so some details about SCION. So I already mentioned this is an inter-domain multipath routing system. So its benefits does have some fast path failover. It can work with multiple operators. And I think its key point is that you can control the path through the internet, at least between SCION-enabled parts of the internet. So these paths are authenticated using a PKI mechanism. They're authenticated when they're discovered through the discovery protocol, and then they're verified when traffic is forwarded. So this really is there to give the higher assurances that packets are going to follow a certain path. The aim is to prevent hijacking, but also that you can geofence your traffic as well. So SCION is based around what we call isolation domains. So these, the better name would be a trust domain. It's a bit of a legacy name, which isn't probably the best description in hindsight. So ISDs are groups of ASs that share this uniform trust environment, which will often be a common jurisdiction. So this might be like in Switzerland, it's a finance network. It could potentially be, you know, an air traffic control system. It could be even a sort of a country level as well. So these ISDs are administered by a number of what they call core ISDs or voting ISDs. So these sort of decide on the terms of joining and the conditions for joining, and they also manage the PKI system. So unlike our PKI, which is essentially managed by you know, a third-party trust route, which is actually the RARs. I think they're a reliable and trustworthy provider, but in some cases, even that is not sufficient for some of these industries. So this does allow you, the core ISDs, to run their own certification authority in PKI to verify all of this path information. So this is done, the core, what they call a trust root certificate, is negotiated by these voting ASs. They establish the CA, and then that issues individual certificates for each of the ASs within when they join the trust domain. So SCION is not dependent on BGP. It uses something called beaconing, which builds up essentially availability through what they call path segment construction beacons. Each AS will have something called a control service, which is actually comprised of a number of different servers, but this will actually go out and build up the accessibility, firstly within the ISD, but it can also build up availability to other ISDs as well. So it's very important to highlight that the isolation domain, you can keep the traffic within the isolation domain, but you can also have policies to send traffic to the other isolation domains as well. So you could have finance networks in different countries, they can exchange traffic. But the traffic you exchange is dependent on the policy of the ISD, and it can also be dependent on the policy of the individual ASs as well. And then the data plane, that essentially runs on IP, but it adds some SCION routing information into that. And then this is used by SCION-enabled routers to forward that between different ASs within an ISD. So an AS, you can just leave your AS. It can run, you don't need to do anything within your AS. You can just run your normal intra-domain protocols. What you do need to do is install SCION-enabled routers. At the moment, you can buy these from a company called Anapaya. There's also an open source implementation that will run on, well, I mean, it's running on Linux boxes. But in principle, this could also be, you could put a SCION stack on some of the more popular router vendors. We're talking to a couple of the larger ones at the moment to support this. So then the important part here is the control services. This doesn't have to be a single point of failure. These can be resilient as well. But that's the sort of clever part that's doing the path construction and storing the path mappings. And that's also doing the certification, caching the certificates and doing the key management for the inter-domain communications. So perhaps another benefit is, as well as the trust and the verification, this actually does switch paths pretty quickly. So it doesn't rely on BGP convergence. So the sort of potential paths through the network are actually discovered and then stored by the control services. So if there is a failure in one of the path segments or in one of the paths, actually it can switch pretty quickly. And experience has shown that this will switch within 1 or 2 seconds. So this is quite important for certain use case applications. Oh, the other thing that I can mention as well, you can also choose paths based on certain parameters. So this can be, for example, based on geographical or geolocation information. But you could also choose this based on, potentially sort of environmental cost efficiencies. So, what's the most green path through the network, for example. So you can choose different policies on how you build up your paths through the network. But I do want to, just dispel some myths here, because I think there's been some, sort of discussion around this. One is that, is SCION trying to replace the internet? The answer is no. So SCION does work with the existing internet and can work with the existing internet, but it's really trying to address some of the shortcomings of BGP for particular users. But it's really trying to introduce this concept of trusted domain, trusted ASs, and where the traffic is actually being sent. Is SCION just an experimental technology for researchers? Well, it started out that way, but actually this is deployed in a production use in Switzerland for the Swiss finance network, the Swiss healthcare network, and there is also a research and education network which covers quite a few countries as well. There is a commercial implementation. There is also an open source implementation. So it isn't just developed at a university. And currently we're documenting the SCION specification through the IETF. So the aim is to encourage interoperability and encourage other implementations of this. Already is in use in the finance network. It's used in the healthcare network, as I mentioned, but we're currently being looked at by a number of other industries as well, particularly in the critical infrastructure sectors. This is supported by, I think, at the moment, 5 ISPs and at least 1 IXP, not all in Switzerland, I would add. So this is something that is happening, and there is interest in supporting in the commercial sector. So I think I already talked a little bit about SSFN. And again, this was a real-world example of they needed to replace an existing old network infrastructure that was expensive and point-to-point. So they saw SCION as something that will support multiple ISPs and multiple domains, and would provide all of the things they needed from the previous network. So this is currently connecting 300 financial institutes, and is used every day for critical and important transactions. And yeah, this is gradually been there's been a gradual migration over this over the last couple of years. I think in the interest of time, because I was asked to cut this a little bit short, that I'll skip this slide, but there are some lessons learned. So, you know, it hasn't always been plain sailing. We have run into some issues with SCION, it's fair to say. But, you know, as with any sort of new experimental, well, not experimental now, but with any new technology, you know, there's some bugs to iron out. In particular, I think, you know, the inter-ISD path control is currently limited. It works fine within an ISD, but we do need to work more on the inter-ISD side of things. There isn't much experience of that. So, but the good thing is that the path failover has been very reliable. That's something that is a really strong selling point of SCION. So again, yeah, trust that the healthcare network is rolling this out at the moment, is in use. The education network, this has been running for quite some time and actually is spanning several continents. And currently the Swiss power utility network is looking at SCION to maybe replace some of the legacy infrastructure there. But there's some applications there because power is very distributed now, so there's lots of sources of power generation. It's not just in centralized points in power stations. You know, there's solar and wind, and also looking to you know, to use this in smart metering as well. SCION is supported by the Swiss IX, and actually we're really trying to encourage more IXs to support this, because I think I already mentioned that, you know, there's a lot of legacy critical infrastructures are due for replacement. There's a lot of finance institutes that have heard about SCION and are interested in using SCION. And you know, the sort of trusted domain and path security is really important for for quite a few use cases now. So if you're an IX, you may be asked, they may come and ask you about SCION and can you support SCION. Certainly ISPs are having this question, and more are starting to support it as well. So you'll at least have heard about SCION if someone comes and asks you about this. Okay, so there are two implementations. There's a commercial implementation that's used for the Swiss financial network. And there is the open source that's used for the research and education network. So the open source that the SCION Association is currently maintaining. There have been other implementations that have been developed to various extents. So this is a multi-platform, both commercial and non-commercial, there's commercial and non-commercial options. Okay, ITF. So this is really important for us because open specifications are really important for interoperability, and we're really trying to encourage other implementations. Classically, this was documented in a book. We decided that this needed to be really more in a specifications environment, so we submitted this to the independent submission stream at the ITF. This is currently going through that at the moment. It's been an interesting process. We realized that there were some missing things and some things we hadn't thought about, and some gaps in some of the specifications and in some of the technology. So this has been a really useful thing to have done, and hopefully we get a sort of much more robust and better documented protocol from this. This has also raised some interest in the ITF about path security. I don't think we can entirely claim it's down to SCION, but certainly this is a growing topic at the ITF now. There's a number of initiatives being discussed, so it's sort of being realized that, okay, maybe we need to address the path security aspect. It was discussed some years ago. It's sort of coming back onto the agenda now. But there are a number of drafts if you'd like to go and read them, if you're interested in reading those, and they're gradually sort of updated as we progress the specification. Okay, so SCION is not just a single vendor thing. It's a whole community. It's a whole ecosystem. There's quite a few ISPs supporting this now. There's some vendors. We've also got some research institutes working on this as well. And some software implementers. So these come together in the SCION Association. And this was really set up as a non-profit, really to support the development of SCION. The sort of primary reason is to support the open source implementation, so there are alternatives. And just on that, I would say, we actually do have quite a lot of interest from some quite big players in SCION, but their sort of biggest concern is that there are alternative implementations, that it's not a single vendor solution. So this is really important to have developed these alternatives, and that's one of the motivations of the SCION Association. We're also acting as a repository for the sort of standardization efforts, so there is a protocol that people can write against, write interoperable implementations against, but just generally as well to raise awareness of that SCION exists, that it can address some problems that you may have in your use cases, and maybe just take a look at it. And that, I think, is it. I'd just like to point out there are some references. Actually, this is pretty well documented SCION. Actually, the documentation is really good, which is not always common in open source. But actually, the sort of the sort of definitive reference is this book, which you can obtain. I think it is actually online as well. But if you're interested, just please take a look. And that's it from me. Thank you.
Thank you. Thank you, Kevin. I would say the Swiss watch under the English. So really important, really impressive how you managed the time. Thanks, it was a great presentation. And I liked that you talked about SwissX, because I know it's the first and only IX so far supporting SCION. Sorry.